So today our learning objective is to know what our power to a power rule is and our power of a product exponent rule is, and to be able to use them. So I bunched these together, and when I show you how they work in a second, you'll understand why. So if you look at our power to power rule, what that shows us is that I've got these side by side exponents. So I have a to the power of m, and we're going to take that power of m and raise it to a power of n. So when I have a power to a power, we're going to keep that base and multiply the exponents. So we're going to look at our first example. I have I have a base of x with an exponent of 5, and we're going to raise that exponent of 5 to a power of 4. So we're going to multiply those two exponents, so we'll be left with x to the power of 20. So same thing down here. I have a base of 2 to the power of 2, and we're going to raise that power of 2 to a power of 3. So we're going to be left with 2 to the power of 2 raised to the power of 3. So we're going to multiply. Gives us 2 to the power of 6. And then our last step, we would multiply 2 by itself 6 times to give us 64. So I lumped these two together, and here is why. Let's look at our power of our product. Our power of a product is exactly the same thing. The only difference is instead of having one base inside those parentheses like we did in the power to a power, we are going to have more than one base. So we are going to distribute this power into every single base. So we are still multiplying our exponent. You're just multiplying it to the exponent of every single base in the parentheses. We're still doing that side-by-side multiplication. So we know in this A and this B that we learned with our one exponent rule that anytime we don't see an exponent, there's an assumed 1. So I'm going to take that n and I'm going to distribute it to the A. So a to the power of 1, well, 1 times n, anything times 1 is itself. So a to the power of n. And then I'm going to take that n and I'm going to distribute it to my b. So b to the power of 1 times that power of n is going to leave me with b to the n. So my answer would be a to the power of n times b to the power of n. All we're doing is the same thing. We're multiplying that power by the other. We're taking the power we have and raising it to a power. The only difference, we have more than one base, so we had to distribute that power to everything inside of the parentheses. So same thing down here. These both have an assumed 1 of exponent. So 1 times 3 leaves me with x to the power of 3. And 1 times 3, because we're distributing it to the x and the y. Again, 1 times 3 is 3, so we're left with y to the 3. I've distributed that 3 to everything inside. So I have 3 times 4, so we're going to raise the assumed 1 here and assume 1 here. We're going to bring that 2 into 3. We're going to bring that 2 into 4. So 2 times the assumed 1 for 3 is 3 to the 2, and 4 to the assumed 1 times that power of 2 is going to leave us 4 to the 2. Well, we can take that a step further. We know 3 squared is 9. We know 4 squared is 16. And if we multiplied those two together, we would get 144. So they're basically the same thing. The only difference, both times we are distributing that power outside the parentheses to the power inside. The only difference that a power to a power has one base that we're distributing it to, and a power to a product has more than one base of that power is being distributed to. Both times we distribute that power or that exponent outside the parentheses to everything. Just one has one base and one has more than one. Either way, it is still distributing that power to everything in the parentheses. All right, so I am going to review the rules. I'm going to walk you through, and I'll post this chart to our Schoology page. I'm going to walk you through this chart, and then I'm going to teach you a song to help you remember the difference between our product rule, our quotient rule, and these power rules we just learned. So we learned that the product rule stated that if I have matching bases that are being multiplied, we keep the base and add the exponent. So when we multiply, because we know product is the answer in multiplication, When we multiply, we add. And then, so our quotient rule, we know quotient is the answer in division. When we have matching bases that are being divided, we keep that matching base and we subtract the exponent. So multiply, add, divide, we subtract. And I'm going to walk you through these zero rules. So our zero, we know anything to the power of zero is always going to give us 1. The 1 rules, we know anything to the power of 1 is always going to be itself. And 1 to whatever power it is, no matter how many times you multiply 1 by itself, is always going to give you 1. Our negative exponent rule, we know that in order to change the sign of an exponent, if it's on the top, we move it to the bottom to switch the sign of that exponent. If it's on the bottom, we move it to the top to switch the sign. So when you have a negative exponent, take the reciprocal, move it to the top or the bottom, move it from what place it's in, and when you move it from top to bottom to top, no matter, as long as you're moving it from where it was, from top to bottom or bottom to top, you're switching the sign. Make sure you're only moving those negatives, because if you move a positive, its sign will also switch. It works both ways. If you move a positive from top to bottom or bottom to top, you're going to make it a negative. Anytime you switch an exponent from its location from top to bottom or bottom to top, you switch the sign. All right, so then we learned today our power to a power, which is into one base, or our power to product, we're distributing and multiplying into multiple bases. We know that those are side by side because those powers we see are side by side next to each other. And here they're still all at the same level, side by side. Multiply. And here's why I wrote those here. So my first year teaching, I had a lot of kids that would get mixed up with their product rule, their quotient rule, and these power rules. So a teacher told me a song she uses to help her kids remember the difference between these 3 rules. So we know when we're multiplying, we add. When we're dividing, we're subtracting. And side by side, those exponents next to each other, powers to a power, we're going to multiply. So here's how it goes, and it's very simple. Multiply, add, divide, subtract. Side by side, multiply. Multiply, add, divide, subtract. Side by side, multiply. All right, now you sing it with me. Multiply, add, divide, subtract. Side by side, multiply. Multiply, add, divide, subtract. Side by side, multiply. All right, so that might help you. It might not. It usually helps my kids. I love sitting there when they take this exponent laws test, and then you can hear them humming it because they're trying to remember whether or not they need to add, subtract, or multiply. So hopefully that helps you a little bit. So, and I had to retake this, so I'm going to erase this all and walk you through them. So again, we know that side by side multiply. That's what we're learning today. So we know these exponents are side by side, a power to a power, side by side. We're going to keep the base and we're going to multiply those side by side exponents. So 4 times 6, we're going to be left with 24. Again, we're going to keep that base of a, and they're side by side, power to a power. So we're going to multiply those exponents. 2 to a power of 3. 2 times 3 is 6. Again, same thing. We're going to keep that base of h, side by side, power to a power. 2 to the power of 6, multiply. 2 times 6 is 12. Same thing, keep that base of z. We have those side by side, power to a power. So power to a power, side by side, multiply. 9 times 7 is going to leave us with 63. Again, same thing, one base. M to the power of 4 raised to the power of 8. So side by side, multiply. We're going to be left with 4 times 8 is 32. And one more, and then we will go some power of a product, because I feel like power of a power is just way more simple than the other one, even though they're the same thing. We're just distributing because we've distributed these powers into the parentheses. The only difference between this one and the power of a product is that we have one base in these. So side by side, 12 times 5 gives us 60, and we're going to keep that base. Okay, to the 60. All right, so power to a product, we're doing the same thing. The only difference is that we are distributing this power, this side by side. If you look, they're still side by side because they're all at that same level, side by side. We're going to multiply, and when we multiply, we're distributing that power into every single power inside the parentheses. So we're still side by side multiplying just to all of the exponents. So I'm going to keep that first base of A, and we're going to do our side by side. 3 times 4 gives us 12. And then we're going to keep that base of 2 side by side. 2 times 3 is going to give us 6. And that is our answer. Same thing. We're distributing this 2 into the entire parentheses to do that side by side multiplication. My J has no exponent shown, so we know that it has an assumed 1. I write it so that you know it's there, so that you know that when you're doing your side-by-side multiplication, it is 2 times 1, and 2 times 1 leaves us with 2. So we're going to keep the J, and it's going to have an exponent of 2. Distribute it into our first base. Our second base is K, so we're going to keep our K. And 3 times 2, our side-by-side, we're going to multiply. 3 times 2 is 6. All right, again, we're going to do our same thing with our 5. With our next one, with this 4, we're going, and I'm going to put a 1 here because I know there's an assumed exponent and a 1 here. So we have a base of 5, we have a base of A, and a base of B. So that 4 has to be distributed into every single base within that. So 4 times the power of 4 to the assumed 1 in that 5, 4 times 1. It's going to give me 4, so I have 5 to the power of 4. We're going to raise that 8, so that assumed 1 in that A, because there was none showed. So 1 times that power, because we're going to distribute it to the 2. It's going to give me A to the 4, and we're going to distribute it into my last base, because I might need to make sure I distribute that power into every single base. I have an exponent of 2. And 2 times that power of 4 that I'm taking 2 to the power of 4. So we're going to multiply it. That side by side multiplication. 2 times 4 is going to leave me with 8. So it's going to be B to the 8. Now, I sit in class and I'm totally fine with this. You may be asked to solve or put it in simplest terms. If it tells you put it in simplest terms, you need to solve for that 5 to the 4th. It told you right now I'm worried about you knowing the exponent rules. So if on your homework you leave it like this is fine. But if I at some point tell you to simplify, put it in simplest terms, you would need to know that 5 to the 4th is 5 times itself. 1, 2, I don't know why I wrote 2, 3. Oops, if I could stop clicking so many buttons. 5, 3, 4 times. And say that 25 times 25, and then actually solve it out. So 25 and 25. Giving us 625. So I've been very nice about this. You could put 625. A4, B8, or you could put this. Unless it says solve, then you have to have that 625, A4, B8. All right, so on this next one, again, I have a base of 4, a base of X, and a base of Y. Y has a power of 2, X has a power of 4, and 4 has an assumed power of 1. So we're going to take that power of 2, and we're going to distribute it into the 4, into the X, and into the Y. So you could go ahead and say I am keeping a base of 4, base of X, a base of Y, and do all of that side by side multiplication. So I know 2 times the 4's assumed 1. It's going to leave us with 2. 2 times the x is 4 is going to give us 8. 2 times the y is 2 is going to give us 4. And like I said, this is technically right unless it tells you to simplify, and I will take this unless it says fully simplify. Otherwise, 4 squared is going to give us 16, because 4 times 4 is 16. X 8, y 4. All right, and then we've got 2 more. So again, we're distributing this exponent of -2 into every single base. I have a base of 5, a base of x, a base of y. And again, no exponent shown for the 5, so there's an assumed 1. So we learn, well, we know there's an assumed 1. So we're going to distribute 2 times 1, -2 times 1. Keep, and I don't know why it scrolled up on me. Keep that base of 5. Multiply those exponents. 1 and -2 is going to give me -2. We're going to distribute it then into the x, and -2 times +2 is going to leave us with x to the -4. We're going to distribute that 2 into the y as well, and -2 times -3 is going to give us y to the +6, because we know our 5, that negative times a positive gives us a negative. With the x, the negative times a positive gives us a negative, and in that y, we had 2 negatives, which gives us a positive. So we learned yesterday our negative exponent law shows us that when I have a negative exponent, and these are all over an assumed 1 because they're whole numbers, if I move them from that top to the bottom, the sign of the exponent will switch. So I'm going to move this one down and this one down. So I have y to the 6 stays where it is, because if I move it, the sign will change. So y to the 6 over 5 squared, because when I move it from the top to the bottom, the sign of that exponent changes. We're going to move our x down. So x to the +4, because when I move it from the top to the bottom, the sign of that exponent changed. And we leave y to the 6 where it is, because if I moved it to the bottom as well, that would switch the sign of that. And we want our answer in positive exponent form. And you could even go ahead and say y to the 6 over 5 squared is 25, x to the 4th, because 5 times itself is 25. I'm going to pause, and as I say this, you're pausing it. I'm going to pause so that you can copy this, and I'm going to go ahead and erase it so it's out of my way for 12. 12 is our last one, so we are still our power to our power, so side by side, all of these exponents are side by side. They're at the same level, side by side. Multiply. So 12 to the power of 2, we're distributing it. We have a base of 12, base of A, base of B, base of C. So we're going to distribute that 2 into the 12, the A, the B, and the C. So 12 to the 2 to the power of 2. So 2 to the power of 2, 2 times 2 is 4. We're going to distribute it into the A. So 4 to the power of 2. 4 times 2 is 8. So keep that base. 4 times 2 is 8, we said. And we're going to distribute it into the B. And B to the power of 8 to the power of 2. So 8 times 2 is 16. And C to the power of 3. And that power of 3 to the power of 2. So side by side powers, we're multiplying. 3 times 2 is 6. You could leave it like this, or you could figure out what 12 times itself 3 times is. And 12 times itself. So 12 times 12 times 12 times 12 would give us 20,736. A8, B16, and C6, but this is perfectly acceptable because multiplying 12 times itself 4 times gives us 20,736. All right, so today we talked about our power to a power. We know that our side by side, so those exponents, when we have a power to another power, those exponents to each other, or a power to a product, we know the only difference. If I could finish the thought, let me start that over. We know a power to a power those side-by-side exponents. We multiply. Side by side, multiply. We're going to have a to the 6. We're multiplying those exponents. And then we know that the only difference between that and a power of a product is that we are going to distribute whatever that power is on the outside to every single base. So we're still doing our side-by-side multiplication. We're just doing it to every single exponent attached. Well, so every single base, because every base has an exponent, whether it's there invisible or it's an assumed one that you need to plug in so you know it's there. But you're going to multiply every single exponent attached to a base and put in your 1 if it's not already there, because every single number always has an exponent, whether it's shown or an assumed 1. And then you're going to say side by side multiply. Keep your base. 2 times 3 is 6. Keep your base. 2 times 3 is 6. So today we did our power to a power. We know there's side by side multiply. We know a power to a power is just one base. A power to a product is the same thing, side by side multiply, but we have more than one base. And we practiced using them, and we learned and reviewed through our other rules. We know still that even when we get a negative exponent, we still have to simplify our answer, and that all of our other rules still apply. So that's basically what we learned today. If you still have questions, please come to our guided practice today. Otherwise, you can go ahead and get started on the work on this on Schoology. All right, have a great day, guys. Bye-bye.